Hey everybody. Let's do the easiest version of completing the square, which is going to be something that looks like this. I'll show you how the pattern makes sense, and then I'll tell you why you might want to complete the square, and then come back in the other levels to do more difficult problems. Okay, so what it means to complete the square is you're going to take a quadratic equation like this and rewrite it so that it looks something like this. A single thing squared plus a number on the outside, a constant. Okay, so before we tackle this one, let's actually do one that's one step simpler. What if it just looked like that, x squared plus 2x? So I want to rewrite this so it looks like that. Okay, I want you to notice a pattern. Here I have a whole bunch of squared terms, and we're going to multiply them out. Okay, so here when I multiply it out, I've got x squared plus 1x plus another x is 2x's plus 1. Here I'll have x squared plus 2x and another 2x is 4x. Here I'll have x squared plus 3x plus another 3x gives me 6x's. Here I'll have x squared, and then 4x and another 4x is 8x's. All right, here's the pattern I want you to notice. Whatever number I wrote here always gets doubled to produce the number of x's. And that makes sense because whatever number we wrote here gets multiplied by x once when we multiply those, and it gets multiplied by x another time when we multiply these. So you'll end up with 4x and 4x for 8x's total. So it's always true that this number will get doubled when you multiply it out. All right, well, when we're completing the square, we want to go the other direction. We have an x squared and some number of x's, but we want to figure out what number can you write here. And hopefully you see that the answer is always half of whatever number of x's there are. So if my original, well, let's actually do the original problem. So in the original problem, I had x squared plus 2x, and I wanted to figure out that's equal to x plus something squared. So half of 2 is 1. And so now I've got that when I multiply this out, it should be equal to x squared plus 2x, except that it's not quite equal to that. As you can see up here, when I multiply it out, I get x squared and I get 2x, but I have an additional 1 because this term gets squared when I multiply it out. Well, if my original problem doesn't have anything out here, I can't say that these two sides are equal. But what I could do is I could subtract 1 on the outside here. And now I know that when I multiply this part out, I'll get x squared, 2x, 1. And the 1 I wrote right here is going to cancel to make 0 with the extra 1 that got produced when I multiplied out. So that's the last step in completing the square. It's figuring out whatever I wrote here, how much extra is that going to add, and then subtract that same amount so that way they'll balance. So if this was the problem, I know the answer is x plus 1, and then I have to subtract the 1 on the outside so they're the same. What if the problem had been the one that I started with a minus 7 here? Well, what I could do is I could think about the minus 7 as separate. So let's keep the minus 7 on the outside. If I complete the square, if I pretend it doesn't exist and I complete the square just on this, it gives me x plus 1 squared minus 1, like we just said. And then I can keep the minus 7 there, and I'll just combine them together. So I'll have x plus 1 squared minus 8. You can always double check to see if it works by multiplying this out and seeing, did you get this thing that you started with? So when I multiply this out, I'll get x squared 2x plus 1 minus 8. The 1 minus 8 produces minus 7. So you can see that it worked. Okay, so we solved our simple problem. We completed the square to get this, and we know that those are the same because when you multiply this out, you get the first one. Come back in the next video for 2 reasons why it's helpful to complete the square.